Welcome to week 4 of the IEEE PCB design workshop. Today we're going to go over some footprints just real quickly at the beginning, and then we're just going to get into PCB layout. I'm kind of going to go as quickly as possible through footprints just because schematics is a thing and they're great. And then we'll just spend the rest of the time doing PCB layout. I will show you, I did upload an additional file to help speed up your design process so you don't have to place your components. The components are basically already placed on the board. You just need to route your planes and all your traces to complete the design. Just a big, another reminder of where we are in the workshop. We're on the 4th week, footprints and PCB layout. Next week will be an open work session, so I won't really be covering any topics. I might send out another email just like if there's any other things that you want to cover, maybe like a little bit more on digital design or something like that. I could do like a brief presentation at the beginning of next week. And then the rest of the time is just going to be me walking around helping you finish your designs. And then after that we have fall break. We're going to order our PCBs after that, the next week's session. So that's basically your cutoff. The final date is going to be in a couple slides. So just some announcements. We got our ASUU approved, our budget approved, so you don't have to pay anything for this workshop. So you will get everything covered. This will be like solder, your boards, your parts that will be part of it. If you submit your own board, we'll cover the entire cost of manufacturing your board. You just have to send us your design. We also, again, with any alternative project, same deadline. So if you're FSAE, CubeSat, USR, or any of those other clubs who are doing PCBs with us, your deadline is the same as us. So just keep that in mind. The board submission deadline, I believe I set to either October 2nd or October 3rd. I don't remember what I sent in the email, but no, it's either Thursday or Friday of next week. This is just so I have some time to compile everything together, get it submitted, and we can actually order that while it gets manufactured for fall break. You will need to submit your Gerber files, which is something I'll go over today. If you don't submit your Gerber files, you will get your reference file, or you will get the reference design, so you can continue in the soldering portion of the workshop. So don't worry if you don't finish. I know there's midterms right now, so you're completely fine where you're at. Again, I will shill FSAE. We're having our meeting tonight directly after this workshop. Nick Howard and Owen are over there, are going to be present. Maybe a couple of you also. There's also our overall meeting directly after Tractive, so if you want to stay here until like 8 or 9 o'clock, that's always an option.
It won't be that late.
Well, I'm hoping it's not that late. I did reserve the room till 9, so just in case we need the space. Last thing, IEEE Discord. If you're already in it, great. This is just formality, but it's there. So, any questions before we get started? Alrighty. So I'm just going to do a quick refresher on component libraries. So libraries are components, are collections of components and footprints. All components must be derived from these files. So you can have different projects reference different stuff in these libraries. You can use them across all your projects if you want. These are relatively consistent across all platforms, whether you're using KiCAD or Altium. There's basically going to be some way that the ECAD tool is going to be managing all the different components. Typically, there are 2 different types. There's the symbol and component library, or the symbol and footprint libraries. These are tightly coupled together because if you have one, it typically is tied to another. So if you have a part, you have a schematic representation, and then you have your physical representation. In Altium, you'll see these files. I presume you're pretty familiar with at least the first 2 since we've already interacted with them, but the schematic library is all the components symbols, and the PCB lib will have all the footprint information. Today we're going to go over PCB lib files. I'm just going to show you how the interface works, and then how to basically tie your footprint to a component. Finally, there's the lib package, which we're not really using, but that's one way to basically make sure that your schematic library and your PCB library files are going to be tied together in an organized manner. For KiCAD, you have the symbol files and the .pretty, which is more of a folder. It's kind of strange, but that's just how they do it. If you're using KiCAD, the process is essentially similar. There may be a tool that's kind of similar for putting stuff together like the lib package, but usually you're going to be using your preferences manager if you're using KiCAD. So yeah, any questions about component libraries? Just a brief refresher on what we're doing? Nope, alrighty. So I want to talk a little bit more about footprints. Last time I kind of just skimmed over them. So there's standard and non-standard footprints. Over there you can see those are a bunch of different parts and the footprint that would typically be assigned to them. So like BGA, QFN, SOP, DIP is probably one you're very familiar with in your circuits labs. But these are basically standardized packages with standardized dimensions that are used across multiple manufacturers. So if you go to TI and you want a DIP 8 package, this will be the same as a National Semiconductor DIP 8 package. You won't have to worry too much about the differences in the manufacturer. But there are certain components that are non-standard. For instance, there's like a power supply module, which is basically a PCB that has its own footprint that you integrate into your own PCB. That will typically have its own footprint that you will have to either design, or the manufacturer will provide it, or you'll have to create it from basically a data sheet. Those ones you may run into sometimes, but for the most part on this board, I believe most of the packages are standard. We won't have to create anything too custom. Specifically with resistors and capacitors and some inductors, not all inductors. I mean, not all resistors or capacitors either, but there are, oh, I just copy pasted the text. So basically in that diagram, there's a bunch of standard sizes. So you'll see like 0805, 0603, 0402. There are two different codes. There's the imperial size and the metric size. While I love metric, we're going to use imperial for the measurements of these components. So an 0805 package, which is the parts we're going to be using, refers to the imperial 0805. The metric equivalent is 2012, which we are not using. If you go to DigiKey or Mauser and all of those different platforms, they'll have like an imperial metric code or imperial code and a metric code. Typically, we'd use the imperial. This is pretty standard across basically all industries. You won't typically buy from the metric side, but for consistency, everyone uses imperial from what I've seen. So any questions about those footprints? Disregarding that text that is duplicated that I forgot to update? No? Alrighty. I'm not going to jump into Altium quite yet. I'm going to talk about the Gerber files that I mentioned earlier, which are what you're going to be submitting to me. So Gerber files are the files that are going to be sent to your manufacturer. So that's what they actually see to get their boards made. Some engineer at the fabric will basically look at your files and then generate some extra files that the machines will actually use to manufacture your board. So this will be like all the stencils, all the photo masks that will be necessary for basically manufacturing your board overall. Luckily, pretty much every EDA platform will generate your Gerber files, but I would still recommend reviewing your Gerber files, making sure that what you expect should be there is actually there. Sometimes, I know in the past we've had like text. So we have our silk screen layer, we put text on our board, it doesn't appear on our Gerber files because we accidentally either put it on the wrong layer or it's just not manufacturable and it didn't get translated into our Gerber files. So I will show you the stuff that Altium generates. You'll use a CAM viewer that helps you view and visualize all the different, like the actual output of your Gerber files. In addition to Gerber files, you have NC drill files. So Gerber files typically have your layer information, so your silk screen, your solder mask, your copper, and if you have internal copper layers, that's also going to be contained in there. But that doesn't have any of the hole information. So NC drill files are where the manufacturer is going to actually drill holes into your PCB. So this is all your vias, all your slots, all your mounting holes. All of this will be contained within these files. You can kind of see in the bottom over there, it's basically a text file with a lot of different information regarding like what tools are going to be necessary to drill these holes, where the location of these holes. And you would send both the Gerber and drill files together to your manufacturer, and they will align them together and basically manufacture your board. And some of the file types, there's quite a few of them. There's typically, these are the ones that you're going to be most familiar with. Altium will generate some additional ones. You can send them into the manufacturer. If they don't need it, they typically just ignore it. But you have all of those extensions. I'm not going to read off all of them, but they contain basically the silkscreen, solder mask, solder paste, copper, and your board outline. And you have a top and bottom reference file for each of them. So you have like GTO or GBO, referring to top or bottom layer. But every single one of those files represents one layer of your board. So you won't have any external or extra information in there. And then you have your drill. Sometimes it's a drill file, sometimes it's a .txt file. It's all ASCII. This is like a vestigial artifact of the Gerber file standard from way back in the day. But yeah, any questions before we open Altium? Alrighty. So let's go open Altium. And if you don't have Altium, this is being recorded, so you're totally fine if you don't have it open right now. But I'm just going to briefly go over how to make footprints. I showed you earlier, it's basically going to be this PCB lib file, and these are going to be linked to basically every project that we're going to be using. The little icon is like an integrated circuit with a symbol near it. We're going to create a new one. So if you already have a project going, so the project I was working out of last week was USB-C PCB, you can right click on this project and we're going to add new. Okay, so we're going to add something new to this project. We're going to add a PCB library, and that should just open up this new window. This window is very similar to the PCB layout window, except this time it's specifically for a footprint. So a footprint that we're going to create today is the 0805 package for a resistor. If you look at, that's the blank. If you look at the schematic, these resistors, all of these are 0805 packages. And if you look at the properties for these, you'll see it's referencing a footprint. Wow, my computer is very slow today. It's going to be referencing a footprint called here, footprint name resistor C 0805 in some library. Mine is referencing a library you don't have, but yours will probably reference the correct one. So that part, if you're going to look at the other library that we have, which is the USB-C power supply library, which you should have imported last week. If you don't have this, this is also in the GitHub under the Altium component library. In here, in the PCB library, you'll be able to find the resistor that we're trying to make. So it looks like this. This one was imported from Schematics, so it actually has a 3D model. But we're going to just make two pads together that will be able to fit in an 0805 package. So what you would want to do is you're going to go to Google and you do 0805 like dimensions or pad dimensions. And you can see that there's a bunch of resources, and you'll typically see something like this. I neglected to add this earlier to the GitHub, but if you look up 0805 pad dimensions, DigiKey has a resource. There are a bunch of resources out there that will be from different manufacturers recommending what their pads look like, but this is what I'm going to reference today. It's from Vishay. They're a resistor manufacturer. They make a lot of different parts. But here is all of the critical parameters for wave soldering. We can choose either one. I'm going to use wave soldering. But you can see in the diagram there's like these different dimensions, X, Y, G, Z, and then you have like a little keep out. This is 0.1 for your solder resistance. No, that's a keep out. So from here, I'm going to go to the library that's blank. And by default, you're going to have one component in here, which is just so the library has something to look at. I'm going to rename this right now. You click Edit, and I'm just going to say resistor or RES 0805. And then I can just enter that in. It changes the name in this window, and we're ready to start. So who's having issues with getting to this point? Or is anyone having issues? Alrighty. So I'm going to place, basically this is two different pads. So you can use the pad tool, place pad. And yours might look different. Mine was probably from a previous project. But you're going to get probably a through-hole pad. What are people seeing when they click that button? Do you see like a circle? Okay. So clearly, the stuff on the right is not a hole. So we're going to have to change that. I would hit Tab, and you're going to get the Properties window to pull up. There's a bunch of information in here, which you're probably somewhat familiar with. So we have designator. Designator is going to be your pin number. Right now my designator is 8. That means it's going to be assigned to pin 8, which was the same number that we assigned to the component in the schematic symbol library. So you got to make sure these actually line up. If you don't, your pads basically are useless. So I'm going to just start with 1. On the layer, we're just going to use top layer. and it gets rid of that. So this basically compacts it down to a single pad. And then if you keep going in this window, you'll see that there's a bunch of other stuff here. So you have like the X, Y, what shape it is, round, you have a paste. We're gonna mess with the copper layer right now. So in the shape, this is rectangular. So we're gonna change it to rectangular. In the X and Y, we're going to type in our dimensions for the actual pad that we have. Right now I'm in mil, so I'm gonna change that real quick. I dislike that. So I'm gonna go back. So now I'm in mil, and then I can type in the different dimensions in the X and Y. So X, if we look at 0805, is gonna be 1.5 millimeter. So 1.5. And then on the other dimension, the Y, we're gonna look at what the Y dimension is. It's gonna be 1.4. And we can press, I need to change my designator back to 1. Oh no. And let me just place it. That says 2. I hate everything. Designator 1. So that's pad 1. Yes.
What's the hotkey to switch?
Okay. Yeah, so grid snapping is G, so just tap G. I switch to 0.1 millimeter. And then for this overlay, to change from millimeters or mil to millimeters, is press Q.
Okay.
And then Q will change that. So once you get that, place 2 pads. I only placed 1. Oh my. And just place 2 pads. Why? Yeah. So we got 2 pads. You can see that it's a little bit wider on the top than the side. That means these are sideways, so press space to rotate these. And there you have basically your pads. I'm gonna align these with the origin. And then the next dimension that we have is the G distance, which is basically the difference between the bottom corner there and the bottom corner here, just like it says in there. So I'm gonna measure, which is Control M, and I can actually measure a distance, and it'll show me like, hey, that's 0.9 millimeter. And the distance we need to achieve is 0.65. That might be a little bit tricky because our snapping distance is, oh no. Our snapping distance isn't, computer, hi. Because our distance isn't quite that. So if you measure from here to here, it's 0.7. So the way you can get around this is you can either change your snapping distance to 0.5 or, oh, they don't have a 0.5. 0.25, and then you can manually adjust it like that and try and measure. Yeah, that's 625, so I'm a little bit off. So I'll move it 1 notch over.
How do I measure again?
Control M.
Control what?
M. And once you have that, you can measure the distance between there. The alternative to doing that is you can do math, essentially. If you look at the pad properties, there are gonna be X and Y coordinates. So you can see the X is -1 and 0. And on the other one, it's 0.15 and 0. So that means the Y is aligned, the X is just different. To do the math, you go to your diagram and you say, oh, what's the difference between the center of the pads, because these are all measured from the center, which would be Y plus G, which is a difference of 2.05. So if you look at the properties of this one, you're at X -1. So this one makes sense to be at X 1.05 if you do the math. It's very nice if you have to do like lots of different pads to manually type things in instead of trying to finagle everything manually with the cursor. But that's essentially how you make the 2 pads. I'm gonna center this a little bit more. And then to clear out those measurements, because they're no longer relevant if I moved it, is Shift C for clear, which is a weird shortcut, but that's how it is. So yeah, that's our 2 pads. We want to add a little bit extra onto this, so like a little bit of silk screen. So we can change layers, just like in the PCB layout. There's this on the bottom, there's a top overlay. This top overlay we can use to draw different lines. So I like to put like a little line between there and there. And this just shows like this pad references this pad because on your board you're going to have a lot of them. Yeah.
What did you do to draw that?
So you do top overlay and then in the top the line tool. Yep. Just like in the schematic editor. You're going to be using this toolbar a lot. So you draw that line. The other thing that you could be drawing here is a keep out region, which doesn't seem to be showing in the, where's the PCB view? View configurator. Oh, it doesn't have a keep out. But on other parts, you may see something like this green region. This is in the mechanical layer. This is going to basically be where you don't recommend putting the component, like another component within this region, because the pick and place machine that would assemble your board in an automatic process would have some trouble assembling your boards. If you put them too close, there's not enough clearance between the two components. The solder could stick to each other. Your components could move around because the solder basically has surface tension. It'll pull your component into another one. That could be a short, that could be a disconnect. It's really not desirable. So typically you would have something like this. In this one, we don't have a layer, so we can actually add more layers. I don't remember how, because usually they show up. Yeah, so it's in the mechanical layer. You can add a mechanical layer. I'm just going to call this 15 just for consistency with the others. We can make this a second layer. This is more of an assembly notes. Yeah, here we go. And we have that. So on here, it should just show up on the bottom as mechanical 15. I want to change that color to something more similar to what I'm used to, which is all in this left panel. This is under view configuration if you didn't find it. And then here we can draw a little keep out region. That's a very thick line, so I'm going to change that to like 0.1. Stop. 0.1. And then we can draw a keep out region around it. Typically, some manufacturers will have a recommendation for your keep out. But for now, this is just a demonstration of how to draw different things in the footprint editor. And yeah, that's basically a resistor footprint. Anyone have any issues making that? Or anyone still stuck?
Where did you go to add a layer?
Add a layer. So on the layers and colors in your view configurator, right click, and you can add a mechanical layer. And when you click that, you can name it. I called it mechanical 15. That's just because that's what Semaxis usually generates your keep out regions on. Layer type, I specified assembly notes, but I think you can just leave it NA and it should just create it just fine. Yeah.
Don't have that layer be on the left.
It should be at the bottom. Sometimes you have to search for it. If not, it might be in your panels. And then you can find view configuration right at the bottom. Anyone stuck?
He's stuck.
You're stuck.
I'm just trying to.
I'll give you all a little bit. And please let me know if you're stuck so I can help you because I don't want you to be left behind. But yeah, did you find view configuration?
I'm in the view configuration, trying to figure out how to get it to pop up on the left.
Okay. Is it like on the right or is it like in the middle?
It's just a window that's opened up.
I think you can just drag it onto the side. So it's like that, right? You can do that. Oops. And you can change the color of all these layers to whatever you want. You can make it blue. That's awful. Pink. There you go. But yeah, And then you have two pads and a little line, and that's a resistor footprint. And then something I'm just going to show real quickly is basically how your symbol libraries are connected to your footprint libraries. So if you have your USB-C power supply schematic library, I'm just going to show you, like, go to resistor. In resistor, we had the two pins, designator 1 and 2. And then here in the bottom, you should have a window that's like model, which is your footprint. So here, it has a model resistor, 0805. You can add more footprints. So if you browse, yours should probably just reference the PCB library file. And then you can select any of these different components that are in here. Right now, since the library is not saved, let me save that. I'm just going to save it. Yeah, that's fine. I believe you should just be able to find it now. If you browse. Yeah, so that library I have, I can find the footprint that I made and add that. And you press OK. And now I have two different footprints for that resistor. And you can tell which one you're going to be using if you're in the schematic editor with your footprint manager. So I'm going to open that up and just click on a resistor. You can see both in the properties tab, you can see the footprint that it's referencing. Right now it's still the old one, but you can change this to the new one if we want to. And that would just update that resistor in particular. So when we push it, the changes to our PCB, those will also show up, so we'll reference our actual the footprint that we just made. I would recommend just using the footprint that we have provided, just because it is a known size and I know it works, and it has a little 3D model. 3D models you can import separately. There is I will show you real quickly once I do that. There's this little, looks like an IC, place 3D body. In here, if you have like a step file, you should be able to import it into this, and it'll print this big pink box. That step file is just something I had from something, so I don't know what this is. It's a pin header. And then you can align this however you want with the footprint that you create. So sometimes Semaxis will only have a 3D model and not a footprint, so you have to make your footprint. So you get your practice making your footprint, but then you'll have to align the step file with your actual, what you create, essentially. Unless you don't want it. You don't have to have it. Because typically, the manufacturer will only see your footprints in your Gerber files. So, yeah. Any questions? Did you get unstuck?
Yeah.
Okay, perfect. All right. So I'm just going to move on real quickly and show you how to make Gerber files. And then after that, I will basically let the time be for work, and then I'll walk around and see where everyone's at. So I'm going to demonstrate how to generate Gerber files. You can technically generate Gerber files from, if you have like a partially completed board. I would recommend not doing that, just because you'll generate Gerber files now with an incomplete board, and you might submit those incomplete files. But I'm just going to show you right here and now. So we have a completed board. We're going to need to go to JLC PCB and see what their manufacturing, like what they want to see in their Gerber files. So in JLC, you can go to their Altium Gerber. If you look up Altium Gerber, they have a nice little instruction guide. They have some specific settings that they would like to see. Oh, I think they've updated this since, yeah, this has been updated. So they have a lot of different instructions here that are a lot more relevant to the current version. They used to have like the 2018 or 2020 version of Altium. So all these settings are covered here. But just to show you, you're going to be in the schematic editor. I'm going to move. Oh no. Where did my project window go? Yeah. So in File, we're going to do fabrication outputs, and then we're going to use regular Gerber files. Gerber X2 is a new addition to Gerber files, which helps to add a couple new features. JLC accepts regular Gerber files, so we're going to use that. And that should bring up this new window. And the default output, so you see all of these different file extensions, like the GM, the GTL, GBL, all those files that I covered earlier in the presentation, those are present here. If we go back to the reference on the browser, you can see there are the different, can I just open this in the new tab? Oh my, why is it so small? But there's all the different settings that they recommend. So make sure in inches and your precision is down to 0.01 mil. They have all their layers. So if you look at all the copper layers, they have all of those selected. But they do not select any of the mechanical layers because they don't really need that. So here we can see we have all our layers selected besides mechanical. So we don't have any of our mechanical layers selected. So we are inches, 0.1, file name, and if we go to settings, all those are the same check. And then if you click apply, you'll generate Gerber files. Those Gerber files will be in generated, or those will be in a folder if you explore on your own file. Oh, that's the wrong one. You'll see that in the project outputs, it'll generate all of your Gerber files together. And basically, this is going to be what you're going to zip up and submit to us. This is all the layer information. We need to actually generate our holes. So I'm going to do that real quick so we can see what that looks like as well. So under File, Fabrication Outputs, NC Drill Files, you'll get another setup dialog. Go back to the website and see what they recommend. Well, they have a very, no, it's NC Drill Files. So this is what they like. Inches, 2 to 5. And then the first two top. So keep absolute inches 2.5. And you can press OK, I believe. Yep. Oops. Oh, do they? Oh, they want, this is a new setting. They want separate NC and non-plated hole files. So take those two together, press OK. It'll do the same thing. You can press OK on that. And there we go. So in your folder, in the project outputs, you'll have all of these different files. You're basically going to do, select all of this, send it, compress to a zip file. This is what you're going to be submitting to me, and this is what I'm going to be submitting to JLC. So everyone will need, if you're doing a custom board, this is the stuff you're going to need. I mentioned that there's a CAM viewer or a Gerber file viewer. This is all these Camtastic files. Altium has a built-in CAM viewer. So this shows you basically what the Gerber files are showing the fabricator. So you can see in the Camtastic window, you'll see all the different layers that it picked up, and you can turn these layers on and off. So if you want to inspect like just the top copper layer, this is what it's going to look like. This is what your copper is going to physically look like on your board. You need to make sure that, hey, the one important thing is like there's no shorts between any of these wires that are not supposed to be there. If you look at your silkscreen layer, you can see that my text is properly showing up. Sometimes your text will not be there because, oh, what did I do? Hi. Oh, ignore that. I don't know what I did. Hi. My layer disappeared. Oh, there it is. Okay. So, yeah, you can see all the silkscreen, all the text is there, nothing is basically distorted. You can see the top and bottom layers, and then you'll see these holes. Oh. Like this is where your paste goes if you're manufacturing this for a stencil, which I can show you. I brought a stencil in today. This is what we're going to use to help speed you up when you're doing your assembly. A stencil is basically a flat piece of metal with holes in it. You take your solder paste and you squeegee it on. So you'll end up with your board with solder paste in specific locations. So you don't have to manually either use, you probably use wire solder, putting that on your board, or with a little syringe putting the paste yourself. It simplifies a lot of things. And it saves a lot of time. Manufacturers will actually make these when you submit and you're doing like PCB assembly. they will have to have one of these, so their machine will automatically be pasting everything. We're going to manually paste your boards because I'm not a machine, unfortunately. Here's like the keep outs for your silk screen, so you can see like here's all the different pads that basically have a keep out. So yeah, that's the Camtastic viewer. We also have the other one that it showed, which was the drill file. So you can see these are all the different holes that are going to be drilled. You can see there's some slots up here, the bigger holes for the mounting points, the smaller through hole components, like here's the switch, here's the different terminal blocks. All of this information is contained within those NC drill files. So yeah, that's pretty much it. Does anyone have any questions before we basically move on to free time? Yes?
Where can I find, you mentioned a board that had all the components placed but not.
I'm gonna get to that, yes. Any other questions? Alrighty. So, that one board that you mentioned that you want, which I would recommend if you haven't started doing layout, just start from here. I believe in the week 4 files, there's the Altium file reference. There's going to be this file, the unrouted PCB. If you open this file, you can just double click it. You can see all the components and all the silkscreen is already set up. All you have to do is connect everything. So you can reference like the completed board. Let me close some of these. Don't save that. I don't need that. So if you look at the completed board, you can basically reference, okay, what planes did I route? And then you can try and recreate that on this board. Because all the components are placed pretty close to each other, or pretty close to their final location. So you can see like, oh, this net. If you hold shift, you can see the ghost wire highlights. This is a connection that I have to make in a plane. And then if I look at the reference design, that connection is here, I believe. So you can see, oh, there's a plane between the inductor, capacitor, and this other filter inductor, and then a small feedback trace to the feedback resistor network back here. So you can basically reference the two of them as you go. If you already have like a PCB document, you're going to want to remove that. Either you can delete it. So let's say the one I started last week. This is not complete. I don't want it anymore. So I'm going to go remove from project. You can either exclude it, so it won't actually delete it, or you can delete it outright. I'm just going to exclude it. So now it won't reference it. And now I want to add existing to project. And then you're going to add that one board from the week 4, this one. Before I add it, I'm going to make a copy of it because you don't really want to be working out of the repository because this gets overwritten if you pull again sometimes. So you're going to want to copy that and then go to where your own project is located, paste it there, and then open it. So this will reference the board, the unrouted board that's in your project, not the project that's on the GitHub. And you can tell if you did this correctly if the symbol for the PCB does not have like a shortcut arrow to it. So I can show you what it looks like. If you add existing to project and I go to just something. Oh, that's the library. Like I add the completed one. You can see there's a little tiny arrow that looks like it goes to a shortcut. That's because it's not contained within this file or within the same project directory. Don't do that. Typically you want to have everything self-contained within your own projects just because you can lose files if you change like computers. It's going to try and reference a file that does not exist on the other machine. So keep everything together. But yeah, any questions? No? Alrighty. If you want to see a stencil's up here, and then I'm going to basically walk around and see where everyone's at. If you need any help, please ask me while I'm walking around. This is your time to work. Something for next week, since you're all here and present, I will try and get food. I want food. I'm hungry, and we have our ASU budget, so I'm going to try and get us some food for next week. So it's just going to be food and work time. You can ask me questions if you need help with like guidance on specific parts. That's going to be your time to ask. It's more chill. I may have a presentation at the beginning just for like a brief refresher or any announcements that I have, but beyond that, you should be able to design your board. Oh, one other thing I'd like to mention. The reference board that I give you has my name on it, I believe. Yeah, on the bottom layer. You can change that. If you really wanted to get a board with your name on it, you could take the reference design, change the name. I really don't care. But I would really recommend if you get the practice of making your own board. But if you don't have time and you'd like your name on something, change that title. So yeah, any questions before I walk around? No? Alrighty.